Hi, this is Dave. This is part 2 of my DOScember project. Welcome back to DOScember if you're following it because it is a DOScember project. This is the culmination of the project where we took the 2088 XT Bridgeboard, got it working in my Amiga like I had it back in 1990, some 30 years ago, and loaded up my paint program or my drawing program called minidraw, and got it running and found there were a couple of bugs. In this one, I take you through how we figured out how to get that working, and what I decided to do, partly to get myself in sort of the DOScember holiday spirit, if it is a holiday time of the year for you, is I have a couple of gifts for you. The first of which is my 32-year-old program, which you can find links to in the description, and its documentation and an image. Dave's DOScember logo converted to two-color CGA compatible mode. So to go back to where we were at the end of part 1, we had gotten minidraw up, we loaded the image, but we were having a little bit of problems with the mouse driver. So let's start off with that, and then what we'll do is we'll move on to looking at how to run the assembler to build minidraw, and I'll take you through a short walkthrough of the code. You know, it won't be completely in-depth, hopefully interesting if you don't know assembler at all, and if you do know assembler, you'll just see a very familiar sort of pattern for how I built this first real program I ever wrote under DOS. So, and then once we run through the code, I'll come back at the end and do what I've done in a couple other videos, is give you a set of what are hits and misses with the project that I think reasons, things that I liked and disliked about it. And I have a special treat for you. One of them is the gift that I mentioned already, which is the program itself, but then there'll be another one at the end, so come back and check that out. So let's go back to where we left off at the end of part 1, and then launch minidraw. So this was the problem we were seeing before. We can't see the mouse pointer. Should be a mouse arrow right near here. And I'll switch the mouse over from the Amiga to here, which is the left Amiga and the P. And okay, now we see. So now what you can see here up at the top is that it's clobbering some of the text with what should be the mouse pointer, but we don't see the mouse pointer. So we'll quit out and run minidraw again. And now we see the mouse pointer, and we can load pictures. So the question is, who's responsible for that bug? Is it minidraw that's causing the mouse driver not to show the first time, or it's the mouse driver? So I asked RetroTech Chris to try out minidraw and sent him the executable in that image file. And what he found first is this. When he was running on an Oracle VM, minidraw came up just fine. The mouse pointer was there the first time. So that's good news. And I asked Chris about mouse drivers. What does he think I should use? I'd found CuteMouse, the ctmouse.com driver, and so that's the one that he tested with. So first he saw that. Then next he ran it on a thin client machine that he's been working on projects lately with, and that also looked and worked great. Lastly, he tried it with PCMU, emulating the Tandy 1000 HX, I believe, and it came up looking like this. With the program worked fine, but the background was black and the foreground was blue. So while Chris confirmed for me right away that if I use a different mouse driver, we don't have that problem with the mouse pointer coming up. So that could very well be a problem with the mouse driver, which is already suspect because people have reported there are various DOS applications that don't work with it. For instance, CodeView, a popular development tool used in the 80s. But anyway, this on the Tandy 1000, he's seeing blue on black, where the way I wrote the program on the PS2, it's cyan on dark blue. So that's a difference, and that'll be one of the things we'll look at when we get in the code. Why does it look different when you're on Tandy graphics adapter or possibly CGA than it does on the adapter I'm using? Remember, I got a VGA card in here, and the machine that I was using at the time, that Model 80, probably had MCGA, and and we'll look into that then.
So now we're back on the Amiga. We're going to run PC Mono again, but this time we're going to run it without the A-mouse driver. And we're going to set up a serial mouse on the Bridgeboard completely separate. So we'll only be relying on now just the PC Mono application to use the Amiga keyboard on the Bridgeboard. All right, so now we're waiting for the A-mouse on the Amiga because we're not running it over there. We'll just break out of that. So now we have no mouse driver, but we have the keyboard. So what I did is I installed the Qt mouse driver. So we're going to run ctm19min/ctmouse. And that it says installed at COM1 in mouse systems mode. So what I have is I have a generic RS-232 adapter with the DB25 that was already in my Amiga in one of the XT slots. And I found a DB25 to DB9. And I found a ginormous collection of mice. And even one more, this Atlas mouse. These are all serial mice that I acquired in the early 90s. Make a long story short, 3 out of the 4 didn't work. One of them does, and it works with this driver. So let's go into minidraw. And now I'm using that Atlas mouse. Looks good. And I can load the image. I can draw boxes. I can draw lines. And I can free draw. Well, or can I free draw? So what I'm seeing happen here is some of the pixels are drawing and some of them aren't. Now this is so this is another bug that we're gonna have to look into. And at this point, we're gonna have to look into the code. What it looks like is happening is that, say for instance, if I clear the screen and we're gonna use, so box and line was working, free draw. What's happening is, if I go down and to the right, it draws. If I go up and to the left, it doesn't. So it has something to do with clobbering the pixel that you're drawing with the mouse pointer. So if we test it a little more carefully, let's say we start from here and go up and to the right to draw, it doesn't work very well. If I start from here and go down and to the right, it works a little better. It's just the mouse acceleration is causing it to skip like that. If I go down and to the left, that works similarly to down and to the right. And if I go up and to the left, nothing. All right, so that's one of the bugs that we're going to fix by looking into the code. But good news, the mouse is working reliably. So now we're using a separate VGA card and a separate serial card and mouse for the Bridgeboard. And again, just relying on the Amiga for the emulation of the keyboard. So let's quit out and switch to looking at some of the code.
So before we start looking in the code and I give you an introduction to both minidraw and assembler programming for DOS in the first place, let's touch on a few loose ends. So certainly if I'm going to be changing the code, I have to be able to get code to my machine. And if you watched part 1, this machine has no network connectivity, and I didn't even have another machine that can write disks that I could put in the Amiga and read as DOS disks. I couldn't write them. So what I did is I went to my crawl space again and pulled out my trusty Dell Inspiron i8000 laptop that I used from I think about 2001 to 2006. I ran Linux on it. It has a floppy drive, has Ethernet, has a Linux build on it that still boots up and works. So I got that running. And what I needed to do was be able to write DOS floppies in the 720K format, that the double density format that the Amiga can read. So I rebuilt the kernel, added the MS-DOS file system support, so I can mount and write MS-DOS disks there, and that's the mechanism that I'm using. I collect things via the Ethernet port to the Inspiron, write them to the disk there, take that disk, pop it in, drive DF0 on the Amiga, and the Amiga DOS 2.1 software can read that DOS format. So that's how we get things to the machine, and then we use ARead to copy things through shared memory from the Amiga file system to the DOS file system at the DOS command shell. So that implies, of course, I'm going to be cross-developing. All right, so let's talk about a little bit more about the DOS machine and what exactly it is. We know that PC Bridgeboard that I have, it's the PC hardware that we run on. It has a BIOS chip on it, which contains the code that provides all the functionality described in the IBM ROM BIOS book. This is the one that I used when I was in a course in college in 1988. And those functions are all implemented in that ROM. Now, if we're talking about DOS, then DOS is the layer above that we load usually from floppy disks or from the hard drive. And there's that layer that provides a whole nother set of functionality. And then lastly, what we just got finished solving was a problem with the mouse.com driver, which is a DOS application implemented as a TSR, terminate and stay resident, that comes in and is installed by DOS. So those are three different layers that we're working with: the BIOS, MS-DOS functions, and the mouse driver. And minidraw must be talking to all of those, right? So that's the framework in which minidraw runs. All right, I think we're ready to go to the code. Let's dig into minidraw. I'll add some links here to where you can pick up source code, the manual for it, and the image files that I'm going to provide you. And you can follow along if you happen to want to. Otherwise, let's just go take a tour of the code. All right, for those of you that are going to download the source code and install an assembler, if you don't have one already, let's start off by showing how we build minidraw from the source code. So I'm in a directory where I have minidraw.asm. That's a source file with 581 lines. And I've converted it to compile with a compiler called UASM. It may compile with other compilers, probably the Microsoft assembler, but I've only tested it with UASM here on the Linux machine that I'm cross-developing from. I have the UASM compiler installed. The Linux version, if I ask for the usage information, it looks like this. So basically the option, you give it the assembler file. Okay, so let's give that a try. Let's run UASM and have it assemble into the machine code minidraw.asm. Okay, so it says 2 passes, 5,000 milliseconds, 0 warnings, 0 errors. So that looks like success. So what did we do there? Well, what we did was we built an object file, which is not what we want. We want an executable because this is a standalone program. It just has one file. So to get that, you run UASM with the -mz option. These are the initials of the Microsoft employee, Mike Zibikowski, that was an early Microsoft employee that decided what the format was in MS-DOS for an executable. So we just say, this time run UASM to assemble minidraw.asm, but this time I want you to produce an executable instead. So here's the result we get. It says 2 passes, same amount of time, 2 warnings, and 0 errors. The 2 warnings, it turns out they happen to be innocuous. It basically says, I didn't define a stack and I don't have a start label. These are things that apparently are optional. But now what we have is a file called minidraw.exe, which is 746 bytes. And if we look at what type of file it is, sure enough, Linux says, well, this is a MS-DOS executable MZ. And now that you have that minidraw.exe, you can take that, get that over to your DOS machine or your any DOS machine, and you should be able to run it. So I'm in a directory where I have the minidraw.asm source file. And let's just give that a look. So what we have, this has some signatures that suggest that it's Microsoft Assembler, this directive that says make the segments alphabetical. Some of the keywords like title, semicolon lines are comments. So that's just a preamble. And then on the PC and in DOS, portions of the program are organized into segments. So what we'll see first here is that there's a video segment, then followed by a data segment, and some declarations of essentially variables. So this source file is 581 lines long. it's going to be hard for me to show you that, right? So let's find a way to summarize it. So when we were looking at it just now, we can see, for instance, that there are a couple different kinds of lines. There's comments, there's declarations about sections of the program, like for instance the data segment here. And then when we get down to the code segment, there are procedure definitions, and then these indented lines are the actual assembler instructions. So for instance, the move instruction, the interrupt, the load effective address, increment, compare, jumping on zero, and those are mnemonics for the machine language instructions. This happens to be ones that are specific to the x86 architecture. So anyway, to summarize this then, maybe one of the things we can do first is let's look at the organization of it without those comments and without those indented, detailed instructions. Let's get an idea of what the gist overall is. So what we're going to do here is throw away lines that are just comments. They have optional white space followed by a semicolon. Then we're going to select lines that don't begin with spaces, and that'll get rid of those commands. And then we'll also get rid of lines that have colons because those are labels, and this is what we have there. So this is a simplified look at the program. We have a video segment, complication having to do with, in this case, CGA, that we won't get into right now, but basically that's where the image that you see on the screen is going to be stored, and the program needs to refer to that specifically because it saves and stores that, or saves and loads that from the disk. Then we have the data segment here. And if we look at that from the beginning of the data segment all the way down to where it says end segment, we do things like declare the menu text, and it's just this text string with those menu options that you see in the application. And then there's a set of variables of my own choosing. And dB here means defined byte, DW means defined word. In this case, we're talking about defined byte is 8-bit character, and defined words are 16-bit words. And then we can go down to the code segment, and the code segment down here, it says it has a bunch of procedures followed by end procedures. So there's a procedure called main, a procedure called menu, and these are like in a higher level language, essentially functions or procedures you would call. The difference is here is there's not a stack construct that I'm using. What I'm doing is using these global variables essentially that were in the data segment instead. So if we page down a little more, here's the entire code segment for minidraw. It consists of a set of procedures: main, menu, free draw, box draw, quit, save pick, load pick, clear screen, line draw, and then draw line, and less than 45 degrees and greater than 45 degrees, and that's the end of the code segment. So so now it's a little more easy to grasp how this is organized, right? So let's jump down to the code segment and see how this program begins. So basically it has a main procedure, and in there, let's take one of the very first action here. Now this is a call to a BIOS function. 10H is a BIOS function. It's the ones that were in that book that I was telling you about, that I was using when I was in the class, the IBM around BIOS. And we can just look this up in here. And here we have interrupt 10H, and what it says is set video mode. Okay. So, and then you can see my comment there. I said 640 by 200. So those three lines there are the ones that are responsible for putting minidraw into the 640 by 200 mode. So that's basically the calling convention. It's a set of series of things, at least when you're calling into the BIOS or into DOS, when you're calling out of your program, it's setting up these registers as, essentially variables that those particular interrupts or those functions use, and then you call interrupt 10H and control jumps into the BIOS and does something. So in this particular case, that 6 means put it in the 640 by 200. It happens in this case 16 color mode. Make sense? So now that I've introduced you the idea that I said these BIOS functions are these interrupts, let's look across the program and say skip past comments, which I'm doing right here, and then if the first word on the line is int for interrupt, then let's print the second word on the line. And what that'll look like is, well, let's run it. So we basically get a list of the interrupts this is doing. So now what we're looking into is what is minidraw relying on from DOS and from BIOS. So we can sort those and we can count them. So what we see is minidraw only calls interrupt 10H, 21H, and 33H. We know from the ROM BIOS manual here that interrupt 10H is calling into the ROM BIOS, so beneath DOS. 21H happens to be a DOS function, and 33H happens to be the only way minidraw gets its input, which is a mouse function. So what we can see here is that a way to summarize minidraw just by looking at the text here is that it relies on the BIOS, it relies on DOS, and it also relies on a mouse. And that makes sense because we know that that's the way the drawing program works, right? So over the last week or two, I was doing changes to minidraw, right? And I was changing things, like I'd put the date in there and stuff. And so what I've done is used, because I'm on Linux here, I'm using development tools that I'm used to that aren't necessarily so common to use under DOS, but they're period correct. These are some of the same commands and editors you would use in a Unix environment at the time. So let's look at the revisions that I've done, of which there were 10 revisions to minidraw, to start with the one that I wrote in 1988 and take it through now. Clearly you don't want to watch me go through every change that I made to minidraw or look over those hundreds of lines of code. So let's just look at one example, and then we'll go back to running minidraw and see if the change worked. I've given symbolic names to the changes that I made. So I said, let's look at it in detail in just the last example when RetroTech Chris helped me look at, by running these on his Tandy, we found that the colors were wrong. Well, CGA, technically, the early versions, is a 2-color screen, and one of them has to be black, so we better use a foreground color that matches that. So that change was affected in 1.9, and 1.7 is the previous one that I did something significant with. So let's look at the difference between the revision called CLC and the revision called CGA. Okay, well, this is the whole thing. I changed something to do with comments at the top. That's just me preparing to release the source code to you. And then I added something to the data segment. I actually added bytes in the code that put the name of it in there, the revision, and the message that it's released in the public domain. So if you just find the executable and you run, say, for instance, the strings command, or look for ASCII strings in the executable, you'll find that information. So you'll know what the program was and what revision that it was. Anyway, the change itself is here. Take out these 4 lines and put in these lines. So all I did was comment out these 4 lines, and they were load AH with the value B in hex, load BH with the value 0 in hex, move the number 1 into BL, the low byte of the BX register, and that specifies the color, I said, and then call interrupt 10H. So these are the lines that were responsible for the original minidraw having that appearance where it was cyan on blue. And what we did is, after talking with RetroTech Chris, I put a comment in here to that effect. When he ran it on the Tandy, it came out as blue on black, which was just ugly and hard to use. So we decided, or I decided, based on his help, was to make it more compatible with CGA and the Tandy graphics adapter by not doing that, and this left it as white on black. So you get that, that bright white in CGA that causes your eyes to bleed on black instead. But that makes it more compatible and will run correctly now on both the Tandy and or other early CGA-like systems. So let's jump back to looking at the program and seeing how the current version of it works, the one that I released to you.
All right, let's boot the Bridgeboard. Go into the minidraw directory, substitute A for C:\minidraw. And the new version I have called minidraw 2 here. Let's start that up. First thing we notice is it's black and white instead of cyan on blue, so that's the CGA version that we talked about. And let's click load with the picture that I'm distributing to you. All right, there we go. You know, we've got the picture we expect. We can clear it, we can load it again. And let's see if some of the fixes we changed worked. Well, that one works. It draws the menu after we load an image. That's good. One of the other significant changes we made was that FREEdrawing. Remember before, what would happen is that you couldn't draw from a point up and to the left. So let's try that. Sure enough, we can do that. We start at the same point and go up and to the right. We can do that. Down and to the left, that works. Down and to the right, that works. Cool. So let's load that image again. And we could do something like, you know, if you've got the balls to change Dave's image, we could make it a happier holiday. Maybe some more exotic hat than we had before.
So this is 7.16 megahertz. This is super nice. Draw a box. Very nice. The line. Oh yeah.
Load it again. And there we're back. So that's what we wanted to do. Looks like everything's working. This is the version I'm, you know, giving to you as a DOScember gift. So let's wrap it up.
Well, that's my project. Getting minidraw working on the 2088 Bridgeboard. It was a lot more work than I expected, but let's go through a couple of details about it. So, of course, minidraw, it's a really simple program, but a simple programming gives you an idea of what it was like to code under DOS using assembler. So what were the misses in this project? Well, the misses were, first off, software incompatibilities in the Amiga 2.1 software. You know, it has everything to do with why I couldn't get the Bridgeboard working with my Fusion 40, and I'm anxious to stop working with the Bridgeboard so that I can get back to my machine running 26 times faster than it does with the 68,000. Clearly, I took out the Bridgeboard in the first place because of that. It wasn't because I needed the space, it was because of that incompatibility, and I believe it's possible, or potentially possible, to get it working with Amiga 3 software or something else, but I'll save that for another time, maybe, and maybe never. Another miss, PC mouse weirdness. 3 mice that didn't work. I don't know what's going on there. I don't know. If anybody wants 3 blind mice, I got them for you. Really frustrating. I was so happy that RetroTech Chris helped me out with that by testing on his machines, because I just didn't have another machine. So what are the hits? It was fun to get a glimpse of my code before I knew how to code professionally. That was, I mean, it's humbling, but at the same time, it's interesting, right? I mean, it actually did something. It was probably better than most of the other students' projects at the time. Another hit, PC BIOS. PC BIOS is super interesting, or I mean the combination of DOS on PC BIOS, because sometimes it did what I mean. And what I mean by that I didn't realize before, because I didn't think much of DOS and PCs, is things like the separation of the video modes from the adapter cards. I'm choosing video modes that work with different adapters. That's really neat. The text menu in minidraw, I rendered that just with one call, you know, and it wrote that across the graphics screen. So it's text, it's the text font written on the graphics screen. That's cool stuff. That's getting towards you know, a nice programming environment that the operating system offers, that it kind of does what you mean and doesn't make it too painful to say. Of course, that led to some of the complications, but I like that do what I mean sort of behavior. The next thing that I really liked was cross-development, because I'm a Unix aficionado, and I've used Linux for decades, and being able to do DOS development on the environment that I like, with the editors I like, with the assemblers on the other platform, super cool. Liked that a lot. And then lastly, the last big hit was the retro community friends. That was an invaluable help. I met people just because of the project. I hope that comes as good news to the ears of the people that organized DOScember. You know, you met a lot of new people, found a lot of new channels, and there's a lot of people doing cool stuff out there. So kudos to the people that organized it. I really thank you for doing that, and keep welcoming people to the community when they have something to offer. So let's close out here. The last thing I have for you, you know, I'm going to keep doing some of my assembly programming, making my listing files and checking them twice. But one of the things that I did along the way, just for fun, that image file that you can download, that's a gift for you. The first one, the source code in the image file itself is unwrapped. The next one's wrapped, and you're going to have to figure out what it is. What I've done is I've hidden an Easter egg in the DOScember.pic file that you can download. So I'm not going to say it's easy to find based on just what minidraw does or just what I've shown you here, but if you learn or if you know how the CGA display works, and in that video area, I think you could find the Easter egg I've left there. If it happens that that no one finds it, no one opens that particular present, I will certainly be giving some hints, and when someone does find it, we will do a postmortem, or I'll decompose how it was that I made it, and I'd be happy to hear from someone how they found the Easter egg that I've hidden in the DOScember.pic file that's UU encoded, and you can get at the URL that's down in the description. So that's it. Happy DOScember, everyone. I have the week off. I'm going to have a lot of fun. I hope you have a good time with you and yours as well. Take care.